Yes students, welcome back to my channel Mechanical Engineering Made Simple. So in the earlier video I have given the solution for strength of materials in the part 1, the solution for 12 questions. So in this video we will start for the solution from 13th question onwards. The 13th question, so normal strain and longitudinal strain ratio is given. So mu is equal to Poisson's ratio is equal to normal strain by longitudinal strain. Longitudinal strain is given as 3 times the normal strain. So I will get, substituting that, mu is equal to 0.33. I know that E is equal to 2G into 1 plus mu. So mu I got 0.33, substitute that. So I will get E is equal to 8 by 3 G. So answer is D. So next question, here two forces are given, in which they are in the first situation they are acting at right angles, and in the second situation they are acting at 60 degrees centigrade. So accordingly, so I have to take the resultant is equal to under root of p square plus 2pq cos theta. So theta is equal to 90 degrees first time and theta is equal to 60 degrees second time. So accordingly I will get under root of p square plus q square is equal to 10 and under root of p square plus q square plus pq is equal to 148. Squaring them I will get p square plus q square is equal to 100 and under p square plus q square plus pq is equal to 148. Substituting p square plus q square is equal to 100, I will get pq is equal to 48. So now I will try to get under root of p square plus q square plus 2pq and under root of p square plus q square minus 2pq. So that I will get p plus q and p minus q. Substitute those values and I will get p plus q and p minus q independently and solve them. I got p plus q is equal to 14 and p minus q is equal to 2. So solving them, p plus q is equal to 14 and p minus q is equal to, I will get p is equal to 8 newtons and q is equal to 6 newtons. So accordingly your answer is B. The next question, it is a sine law. Basically your okay, Lami's theorem is basically a sine law. It is not neither a tan law nor cos law. So other things are only given to confuse you, and according to this the force is proportional to the angle between the other two forces. So in the diagram I have shown, so p by sine beta is equal to q by sine gamma is equal to q r by sine alpha. So is equal to constant, so you can easily make out. So p is equal to k into sine beta, q is equal to k into sine gamma, q r is equal to k into sine alpha. So that means they are proportional to the angle between the other two forces, any force. So in the next question, 16th question, the answer is D for the above question. In the 16th question he has given load and forces and also moment. So for moment you need not do anything for calculating the moment, directly add it, and for when force is given, what is the moment? Load into distance, perpendicular distance. So accordingly calculate all the clockwise moments and any point about the point, and also anti-clockwise moments. Take the conventions. If you are taking clockwise moment as positive, take the negative moment, anti-clockwise moment of negative, and downward acting force as positive and upward acting force are negative, but don't mix up. So for example, if you are taking downward acting force are positive, so stick to that throughout the problem. Okay, so now I will get net force is equal to 4000 minus 2500, that is 1500 newtons, and net moment about the point A is equal to 4000 into 1 minus 2500 into 2.5 and minus 2 plus 2000. So I will get 6000 minus 6250. So net moment is equal to minus 2250 Newton meter. So answer is C. So here in this next question, so your a body is given, a block is given, it is there on the plane which is inclined at 30 degrees to the horizontal. So you have to, in these problems you have to resolve the forces along the plane, inclined plane, and also forces along the perpendicular to the plane. So accordingly I will get resolving along the plane, I will get 600 sin 30 plus mu r is equal to 400. So r is equal to 600 cos 30. So that is nothing but 520 newtons. Substituting them, I will get mu is equal to 400 minus 200 by 520. So approximately it is coming around 0.192. This is approximately 0.2. So you can choose the answer accordingly. So your answer is C. Next question, in the simple machines. Okay, in the simple machine is one in which we apply. So what is the purpose of a machine? Any machine is needed of you apply less effort, but you are able to lift more load. So W by P, load lifted by effort applied, is defined as the efficiency. So mechanical efficiency, mechanical advantage is equal to W by P. Okay, load by effort. So efficiency is given by mechanical advantage by velocity ratio. So that is equal to MA by VR. So VR is also given, it is 10, and load is given, effort applied is given, but here effort lost in friction is given 20% of the effort. So 20 by 100 to 100, that is equal to 20. There is one relationship between PF, effort lost in friction, and actual effort applied, and load and velocity ratio. Substitute them and you will get W is equal to 800 newtons. So efficiency is equal to MA by VR. So substituting the W by P by 10, so I will get efficiency is equal to 0.8. So the answer is 80% and 800 newtons, which is nothing but your A. So here in the next question, 19th question, so it is a rectangular section and a triangular section. So naturally for a rectangular section, the centroidal axis, okay, it will be half of the depth, it will be passing to half of the depth, and so in case of triangular section, it will be h by 3 from base and 2h by 3 from vertex, where h is the height of the triangle and b is the base. So they are always equal. So the moment of inertia of a rectangular lamina about the centroidal axis, which is h by 2 from the base, and also the moment of inertia of the triangular section about the base, both will be equal, bh cube by 12. So it is only to confuse you. You know that about the centroidal axis it is bh cube by 36, okay, for triangular section, but only to confuse you has given, okay, like that. So you can easily make out the answer is B. So now in the next question, the 20th question, a lamina is given, which is L section is given. So you know that for any plane lamina, x bar is equal to A1 x1 plus A2 x2 by A1 plus A2, and similarly y bar is equal to A1 y1 plus A2 y2, like that, okay, A3 y3 also, if third area is there. So you have to actually divide the plane area into the number of areas. So for example, A1, A2, A3, etc. Okay, so A1, A2 are the areas, and x1, x2, y1, y2 are the so reference axis. So he has given left axis, okay, left line and down line, bottom line as the reference lines. So you can accordingly fix up the distances x bar, x1, x2, y1, y2. So you can go through the figure. I have clearly given, substituting them. So area is equal to 10 into 2, 20 centimeter square, and A2 is equal to, A1 is equal to 10 into 2, A2 is equal to 4 into 2, 8 centimeter square, and I have marked the lines also like centroidal axis. So now here the net length is equal to the bottom, okay, 6 meters. For second area, the length is equal to 4 meters. Okay, so you have to consider okay, leftmost line and bottommost line. So you can easily make out that the distances are as given. So substituting them, I will get 10 into 2 into 1 plus 4 into 2 into 4 by 10 into 2 plus 2 into 2, that is equal to 50 by 28. So 52 by 28, that is 1.85 centimeters, and y bar is equal to 10 into 2 into 5 plus 4 into 2 into 1 by 10 into 2 plus 4 into 2, that is equal to 108 by 28, that is 3.857 centimeters. So answer is A. Next question. A body is moving, a particle is moving. So he has given the relationship between the distance traveled and the time. So first, if you differentiate first time, you will get the velocity. So I hope you are good in differentiation. So v is equal to 3t square minus 12t plus 27. If you differentiate once again, ds by dt is nothing but your velocity. So d by dt of ds by dt nothing but d by dt of ds by dt is equal to v. So that gives the acceleration dv by dt. So again, once again, differentiating, I will get acceleration is equal to 60 minus 12, but for maximum velocity, acceleration should be equal to 0. So substituting that, for maximum velocity, dv by dt is equal to 0, I will get t is equal to 2 seconds, and substituting the v equation, velocity equation, I will get 3t square minus 12t plus 27. Substituting t is equal to 2 value, I will get v is equal to 15 meters per second. So that is your answer is D. Next, so impulse is defined as f into t. So we know that from law of conservation of momentum, ft is equal to mv into mv minus mu. Ft is known as the impulse, that is nothing but force into time. So force into time or mass into velocity, both gives the units of the impulse. So force into time means force units are newtons and time units are seconds. So the units of impulse are Newton seconds. Other things are given to only confuse you. So you can substitute mass units also, kg into meter per second. Also that also are the units of the impulse. So next question, he has again given another question like a body is lying on the plane which is inclined at 30 degrees with the horizontal, a force P is applied, 400 newtons is applied. Okay, so substitute that. So as I said, always, so here in this case, when a block or a particular object is sliding or any force is applied along a plane, when the object is lying on a plane, you have to always resolve the forces along the inclined plane and also perpendicular to the horizontal inclined plane. Okay, so now always your friction force will be acting in the negative direction, that means the opposite direction. So accordingly I will get, so normal force is equal to 300 cos 30, that is equal to 259.81, and frictional force is equal to mu n. We know that from frictional fundamentals, 0.2 into 259.81, so that comes out as 51.96 newtons. So the initial velocity is given 1.5 meters per second, and distance traveled is also given here, it is 6 meters. So now, so you have to apply here, applying the work energy principle. According to work energy principle, work done is equal to change in kinetic energy. That means 400 minus F into W sin theta along the plane. Okay, that means inclined plane into the distance moved along the plane is equal to half m into v square minus u square. But we know that m is equal to W by g, weight by acceleration due to gravity. So I already got W is equal to already given, he is given 300 newtons. So substitute that, and only the unknown parameter here is the velocity. So the velocity I got is equal to 8.942, that is approximately 9.9 meters per second. So your answer is D. So now there are two cases in this case. Okay, so a body moving along a curved path. Okay, when the road is horizontal, and the second case is when the road is banked. That means a slight tilting, a slight elevation will be given to that. So in both cases there are two formula, mu is equal to under root of V is equal to under root of mu gr, where mu is the coefficient of friction between the vehicle and the road surface, g is the acceleration due to gravity, and r is the radius of curvature. Substituting that, I will get in the first case, when the vehicle is moving on a plane road, that means horizontal road, but it is taking a curved path. So then I will get V is equal to 12.528 meters per second, converting into kmph, that is multiplying by 18 by 5, I will get approximately 45.102, that is 45 kmph. Similarly, when the curved motion with banking, so that means some angle tan theta is given as 1 by 10. So there is a formula for that. In case of banking, V is equal to gr into mu plus tan alpha by 1 minus mu tan alpha. Substitute that, tan alpha is equal to 1 by 10. So I will get V is equal to 9.81 into all those things, 40 into 0.4 plus 1 minus 1 minus 0.4 into 1. So substituting all those values, I will get 14.298 meters per second. So converting into kilometers per hour, it will be 18 by 5, multiply with 18 by 5, it will be 51.45, approximately 50 kilometers per hour. So choose the answer. So in the options given, answer A is the correct answer. So in case of simple pendulum, so I have shown a simple pendulum over there. So middle portion is the neutral position, and it is going right side, it is going left side. So the total time taken for going right side, left side, again to neutral position, again to right position. So this is the total time period. So time period is the time taken for completing the one revolution. That means it is starting from rightmost position, coming to the neutral position, that means most down position, then left position, again coming down, reaching the neutral position, again going to its earlier position. So this is called the time period, that is the time taken for completing the one revolution. Okay, so here it is the time period for the simple pendulum. Okay, seconds pendulum, it is not second. Okay, simple pendulum, I have shown simple pendulum only, but the second pendulum is defined as the pendulum for the simple pendulum for which the time period is 2 seconds. So that means half revolution it will say take 1 second, and half revolution or half complete. Okay, 1 second. So totally 2 seconds. So length of the pendulum, L is the length of the pendulum, I have shown there. So the mass, m is the mass, and g is the acceleration due to gravity. So the relationship between the time period and the length of the pendulum is given by, simple pendulum is given by t is equal to 2 pi root L by g. So substituting for t, t is equal to 2 seconds. So for the time period for seconds pendulum is 2 seconds. That means half revolution it will take 1 second, and to complete another half revolution it will take 1 second. So total revolution it will take 2 seconds. So time period is equal to 2 seconds. Substituting that, so squaring on both sides, t square is equal to 4 pi square into L by g. So L is equal to pi square g by t square g by 4 pi square. Substituting that, t and all those values, g and 4 into pi square, I will get L is equal to 99.0 39 centimeters. So I have substituted here 981. So it is in centimeters per second square accelerated due to gravity, so that I will get length in centimeters. So the answers are 2 seconds and 99.39 centimeters. So accordingly your answer is B. So with this we have completed the solution for the part 2, which gives the solution for your strength of materials. Dear students, I will suggest you one thing. So all these sections, whether it is thermodynamics or manufacturing technology or your engineering mechanics and strength of materials, so please go through the books, practice well and read well, and after reading only attempt these questions. They are definitely standard questions, and if you have completed the syllabus and got the actual core of the subject, only then only you can answer these questions. But I am once again telling that if you are able to solve these questions without referring to any book, that is the standard you have to get for any competitive examination. Of course, whether it is a diploma level or it is a degree level, that is the standard you have to get. So once you get the standard, definitely you are going to there. But definitely if you are getting some doubts, please refer to my videos. Anyhow, they are available. So if you get any doubt, you go to my previous video also. Also I have given all the questions. So my request once again is that practice, so try to solve these questions or these question papers which I have given, and of course as a reference you can have the solutions at any time. So please follow these instructions and definitely you are going to succeed. I am going to tell that you are going to 100% succeed if your way of preparation is like this. Once again we are going to meet. So once again my request is that if you have not subscribed my channel, please subscribe and share my channel name in your Twitter, maybe Twitter you may be having or you may not be having. So please share in your Facebook, Instagram and also WhatsApp groups to your friends and groups and contacts. That is the only favor which you can do for me, and wish you all the best. Good luck. So prepare well. Let us meet in the next video.